Okay, good afternoon all together. I think I'm supposed to start because we are already a couple of minutes late, and as a German living in Switzerland, I'm not used to starting late. It's not yet Southern Europe. I'm a professor for software engineering and teach C++ and other things, and for the background, that's our campus directly at Lake Zurich. So this summer it was like 30 seconds from office or lecture hall to swimming, if you really were eager to do that. I'm also the, let's say, inspirer of a C++ IDE that we more or less started 10 years ago with the first attempts to do, or more than 10 years ago, with first attempts to implement C++ refactoring. And CVelop is the current release that we have, and we are still working on improving that. And some of the dimensions we are trying to improve that is providing you checkers for core and other safety guidelines for C++, so you get immediate feedback if you violate something. I guess many of you have been to Kate's talk this morning. Who has not been there? Okay. She was saying const all the things or something like that. We actually have implemented that tooling to provide you suggesting to place const, and then we'll do it for you in your source code, just to let you know, as an example of what kind of refactorings we provide. So my lifetime goal is actually to eliminate bad software. I cannot shoot all the non-educated developers, so my task is to educate other developers and change them, making them better developers, like Kate tried this morning as well, and Bjarne is striving as well, and we all try to make you all better developers and making our life better, because today the world runs on software. Now, what are guidelines? This talk is about guidelines. Guidelines can play roles. If you go to someone who is working in systems that are about security or safety critical systems. Okay, who of the safety critical people are using MISRA guidelines? A few only. Let's say guidelines can actually play a role where like in the German Autobahn, where you have, let's say, implicit coordination allowing you to run faster, and separating things like the lanes in the Autobahn or highway. That's one of the roles guidelines can play. Very often they are more seem to hold you back from exploring the world and seeing how things actually work, and they don't allow you to go where you actually want to go. In the extreme case, they can be like the kettle arrangement there, actually just giving you one way to do something, which might not be the best. It might be very boring and ugly, and you don't like it, in the hope that the resulting product will be safer or better. So as a car driver, you can consider what my idea of guidelines would be. And the important thing, if you violate a guideline, if you only learn that in the very end that you violated the guideline, it's very bad. For example, my car has kind of a control. If I just move a little bit out of the lane on the Autobahn, it will actually vibrate the steering wheel, so I can have immediate feedback. Oh, maybe you're not going where you want to go to. And that's that kind of immediate feedback, allowing you to change before something bad happens. That's important for me. This is a kind of a tiny landscape of guidelines, especially about safety and security. We have in the lower corner, we have the SEI, the Software Engineering Institute CERT. We're doing kind of security stuff, let's say, and they have some kind of C++ coding standard. They also have a C coding standard. If you ask me, a system programmed in C can by definition not be secure, at least if it's not done by very, very bright people with very, very highly consciousness and not maintained into a mode where it's no longer observable. I've seen so many badly written C, and I was teaching C since 1986, 7, so a couple of years ago. We have the C++ core guidelines, the main topic that I want to rant about today. But we also have other guidelines and guidelines in the making, like the high integrity C++ by the people from programming research, the automotive industry, which might not be that popular in Norway. You don't have an automobile manufacturer, not here. Okay, AUTOSAR. Well, the Germans have a lot of automotive industry. They try to create new C++ guidelines for C++ 14, and some of the guidelines that they have are already obsoleted by 17, but that's the world. MISRA is trying hard to renovate their C++ guidelines, which stem from 2008. Then were written by Ada programmers who knew some C and tried to provide C++ guidelines, which is how they, when I first looked at them, I said, well, whoever can think about writing C++ in a way that they were talking about. But I learned there are people who do that. And also the ISO group that it's not the C++ committee, but a neighboring committee in the same subgroup on programming language vulnerabilities. They are also working, trying to tell you what to look out for when you're using C++. And let's say all these guidelines inspire each other, sometimes because the same people working on that, on those groups, but also because, let's say, what is good code is kind of sometimes discussable and sometimes not discussable. So there are some rules that are always, if you don't follow that, you're doing bad things. But by some things you might actually consider, maybe in my context it's better to do it that way than the way the guidelines say. So always, if you are forced to use a guideline, all the guidelines come more or less with an overarching rule. Please select what you really need. There can't be a reasonable MISRA compliance without rules that you don't follow. And you have to document that you don't follow them, either in individual places or throughout your project. But there will be rules that don't make sense in your context. So what is the role of these guidelines? If you look at the C++ standard, there's the C++ grammar, which is a superset of what you can actually compile. And there are a lot of text in the C++ library that tells you what parts of the grammar are not allowed or don't make sense, but the grammar underneath is bigger than what you have in the language. Then there are a lot of rules in the C++ standard that tell you what is actually compliant, and most compilers try to follow those rules, but they might actually compile more than what is valid C++. So the first step is, if it compiles, you're safely within the domain that the compiler understands. Sometimes you might even have stuff that is not compiling that is valid, but that's the problem with the compilers. But even that code, by definition, can be not valid because it might encounter undefined behavior. So all safety guidelines want to go where you don't have undefined behavior, because that's a curse. Anything can happen, and I have a nice slide showing you what can happen there. And the biggest problem with undefined behavior is the compiler doesn't need to tell you about it. And some compilers try hard, but even they might not give you all situations where you can have undefined behavior. And warnings help a lot. So who is not enabling all warnings on his or her compiler? Who's treating warnings not as errors? Go home, change your compiler settings, enable all warnings that you can get, and treat all of them as errors unless you can prove that it's not a problem. And then there are the attempt to get understandable and safe C++. Usually that means you rule out even more that's safe and understandable. And as I said, a lot of the guidelines actually have common rules, but sometimes they differ, and that's also some things. What also guidelines typically address rule set violations even up to what's not in the C++ grammar. MISRA is guilty of that. Well, it's because there have been some compilers that were saying we are doing C++ that actually weren't doing C++ when the rules were written. And then we also have the false positives, where the rules disallow something that's quite valid and what you actually want to do. Even the warnings might give you false positives, and that's something also to consider. There will always be rules that either you need to violate or you have no better idea how to write your code not violating it. So undefined behavior. I typically show the pink elephants. Some people say that you get nasal demons. And I just recently, last week or 2 weeks ago, I found a tweet where, oh, there's a t-shirt where the badness of undefined behavior, it can be anything, like a winged unicorn or a rainbow or a balloon or whatever. But actually, you don't know what you're getting. You might not even be able to detect that you get into undefined behavior because the compiler or the processor might do something that looks reasonable, but it's not guaranteed. So watch out. So guidelines try to do a lot of good things, but they also have some bad corners or some issues. One thing is, some are not clear about the underlying philosophy. The MISRA guidelines, they might be clear, but usually they're not perceived like that because people turn on a tool with MISRA checks and then they get a lot of feedback, which means ridiculous error messages and warning. They have no clue where they come from. And without an underlying philosophy, it's very hard to get there. The C++ core guidelines are very clear about this underlying philosophy, and that's good. Some rules seem superfluous or contradictory. A lot of the guidelines can come off with several layers of defense. So when you actually cross one of or disable one of the rules, a next one kicks in so that the badness is not as bad as it should be. So that's why some rules actually don't make sense when you look at all of them, but some of them are only there to give you an additional safeguard if you cross out one of the other rules. Then we have things like, okay, we want to have a safe or a secure system, and the core guidelines might give you indirect safety and security because they give you good practice and disallow bad practice, but they don't address safety and security deliberately. And there might not be, let's say, if you have there are that many in safety critical system, but if you have to provide a kind of a guarantee, then that means you need to have other rules in place. And also, maybe with the exception of the core guidelines, a lot of these guidelines actually don't show you how to do it right. They only show you how not to do it. And sometimes it's also not addressing design. MISRA deliberately tries to sidestep. We don't teach people design. Well, but some designs are really bad. And I'm more, let's say, as a professor, I can be very despotic, so I can just say, do it this way. Or never do it that way. And even so, I know you might want to do it differently. It's easier to get your head around, starting with something that works. Very often, you have rules that you cannot easily adopt because it's incremental. You cannot adopt it incremental because either all your code base is okay or not. Kate had something about const correctness. If you start adding const to a code base that was completely ignorant of const, it's very hard to get it to compile again. So you have to do it consciously wherever. Also, you look at who is actually behind the rules. Very often the tool vendors that actually write checkers or sell checkers, which can be very expensive, are behind these rules. So the majority of the rules are those that are very easy to detect. So it's not that hard to sell a product with that. You might have outdated rule sets because the C++ standard moves along, and except maybe for the core guidelines, none of the rules actually cover C++ 17 yet. And as Nico told us this morning, each new language and library version provides new features to either misuse or do something better. And also they are not taught properly, and it's very hard to teach something that's 500 plus pages, and where you have to do everything like that. The tools are expensive. Who is using, let's say, a static analysis tool for all of its team, or her team, their team? What is the price per seat? Rough?
It's high.
High. So usually at least 1K per seat, maybe 10K, whatever, maybe not krona, but euros or dollars. Plus the setup costs, which can be significant, and regulations often focus on process and not on product quality. If you go to safety critical systems, there are ISO standards that tell you that you have to do something, or you define how to do something, but not that the something that you do is actually good. And if you follow your process, you get your ass covered, so your insurance will pay. And very often, the guidelines get in the way, especially if feedback comes late and it's underappreciated. The problem is you cannot learn to drive rules alone. I try to teach C++, good C++ practice with track signs all over the past almost decade. And things like, don't write assignment operators, use curly braces, you might detect that. Don't use loops, write algorithms, and don't write special member functions. Let the compiler provide the ones that are right for you, some things. And almost always auto is also on that scene. So now let's get back to the core thing, the core guidelines. Their goal is get existing C++ code towards more modern C++. That's a lot of the addresses. I'm not sure Bjarne is in the room. I shouldn't complain too much about the process, how the C++ core guidelines came into existence, because I don't know about that, but maybe he can tell me tonight with a beer. Sometimes I get the impression of the rules, or at least of some of the examples. Microsoft went over their code base and looked for all the bad things in Windows or their programs, and then wrote a guideline for that to not make it happen again. Which might be a good thing to start with, but there's still a lot of work to do to make them great. The good thing is, the underlying philosophy is write modern C++ code and get rid of undefined behavior. Things like good names are universally true. The problem is with good naming, sometimes it's very hard to get there. And usually not being able to find a good name is that you try to do too many things in one chunk. I'm a big fan of not commenting code, because comments are wrong. And if you need to write a comment, it's definitely a chance to refactor your code to make it saying what it is. And that's in the philosophy of the C++ core guidelines. So whenever you write a comment in your code, especially within a function, stop. Think about how to structure the code better and refactor. And I'm completely honest about it. Every code that needs a comment is wrong. It comes with a guideline support library, so that helps a lot to make some things simpler. And that's also a good thing. MISRA usually tells you how not to do it, but doesn't provide you any clue on how to do it better. So some examples are always good, like, okay, one we already have heard about this morning, prefer the standard library to other libraries and handcrafted code. And here we see, okay, we should use accumulate, and instead of a strange loop that goes here, to actually sum up elements in an array. This piece of example code in the C++ core guidelines is a glimpse of the future. We are not there yet. It would use an accumulate that understands ranges. It's implemented already, but it's not standard C++ yet. And loops like that, okay, this is accumulate, quite obvious, but very easily you get into the example, oh, that's a rotate, and nobody understands what the loop is actually doing. And that's something, try to get rid of loops. Every loop is also a potential design problem if it's not encapsulated in a generic function. A function with more than one loop might even be a bigger problem. Another thing that's more obvious is, okay, if you have a non-empty case in a switch statement, it should end with a break. It's very easy to forget that. Sometimes fall-throughs are deliberate, but if you don't see that, it usually is a programming error, and that's something some compilers even complain about. And also we have some students of mine implemented a checker that give you a yellow bug there and allow you to actually fix what you're doing, like adding the break statement, or actually provide a suppress comment saying this is a fall through that's deliberate, but that's documenting the issue in that case. And that's one of the comments that you are allowed to do, but usually a fall through is also a potential problem in your code design and structure. So what are the areas? Some of the areas that are addressed is resource leaks is some common problem, especially C programmers deal with. In C++, there's no reason to have a resource leak. We have RAII, thanks to Bjarne, and we have a unique pointer and other things that take ownership and actually clean up on our own with the garbage collector, that's the curly brace. There is some area where a high discipline is actually required, is using valid pointers or pointing things like iterators. One thing is no raw pointers. The core guidelines actually give you a hint of using raw pointers, and I'm not sure I like it because that's one of the things that's very hard to adopt incrementally. If you have a code base that's using pointers, plain pointers, and then you follow Bjarne's rules about, okay, plain pointer only is a non-owning pointer, you first have to get rid of all the situations where the pointer is actually owning some memory and you have an explicit, or owning something and you have to explicit remove it, delete it. Some things about memory corruption, like accessing out of bounds things, is undefined behavior, so getting rid of undefined behavior. And one thing is, I learned to appreciate even more from working with a colleague who is very good in theoretical things like type systems. The type system of the compiler is your biggest friend. And if ever you can employ the type system to detect an error at compile time, that is what you want to get. Because type systems were invented to avoid runtime problems. And tomorrow I have a talk about how to employ the type system even more to get better with that. So in general, any typecast that you have in your code is a design problem, because you're violating the type system and you're doing something bad to your types, and that tells you that your design could be improved. The last thing is about code understandability, and there are a lot of things of doing about that. Good names are one of them. So my current take on the guidelines, and I'm still a little bit nervous because Bjarne is here, I might criticize his work, but my personal opinion, and it's currently, so that changed over time. The pros are, we have modern C++ style. The bad thing is there are many, many rules, very hard to learn them all. We have safer code, less undefined behaviors, fewer pink elephants. But the rules, some rules must be prioritized to be useful. That's true with all the guidelines. We try to get pointer safety from the core guidelines. Let's go for the pros. We get the RAI, we get parameter passing guidelines on how to pass things down the call chain. We have some good software engineering principles that have been established over the last 25 years or more. We have less verbosity, so fewer code that's not there. I'm sorry. With the hearing aid, it rings in my ears, even on silence. So we have less verbosity. We have a lot of common sense, which might not be so common, so telling you what you should do, but might know that you should do it, but you're not actually acting on it. A lot of getting rid of C-isms and 1990s code. Who has a code base that started before 2011? That's where you're actually the target audience for the C++ core guidelines, to modernize your code base. And transformation guidelines, there are hints on how to change your code base. We get the helper library and static analysis checks, which we try to implement. Some of the rules we have implemented, but not all of them are actually implementable, because how do you define what is a good name? Look it up in a dictionary? Well, we might not have access to a Norwegian dictionary or a Swiss German one. Now, for the bad things, again, some rules only provide the bad examples. You only get the violation signs and not how to do it better. You might be able to figure it out on your own, but sometimes it's not clear what is the better way, or there might be too many to choose from. Some rules cannot be adapted incrementally, like the const thing, for example. Some rules are common sense only. Some rules are very specialist. In my opinion, except for very, very tiny pieces of your code base, you should never get to a point where you need that rule. And you have that throughout your code base. You either have very bad encapsulation, or you're doing really, really hard stuff, which is sometimes the situation. But very often, things like that are done without need, especially if you come with a code base from the 1990s. Some of the things might be too modern for your environment. You might not get a compiler for your embedded device that actually understands C++ 14 yet. But I would say, except for some of the vendors where I know that seem to do it deliberately, choose a more modern hardware can actually improve your software quality a lot. Or at least a vendor that provides a good compiler. I'm not saying which one, but those who suffer will know. And one of the biggest things, when I first heard about it, the marking pointers that own something, I thought it was a great idea. Today, my opinion is owner T is a hack. Because when you mark something that owns memory with owner T, the better refactoring would be using unique putter T directly, immediately. When you touch that code where you mark something as taking ownership, do it immediately, refactor it to use unique pointer. Even if it needs a special deleter object to clean up, don't use owner. The philosophy behind the core guidelines, Bjarne told us last night. Who has been here last night for Bjarne's talk? Okay, so I'm preaching to you. You already know most of it. Write in standard C++ and so on. Don't leak resources. Don't waste time or space. Prefer immutable data to immutable data. Everything that can be checked at compile time that cannot be checked at compile time should be checkable at runtime. But some things we cannot check at runtime. But compile time checking is always better than runtime checking. And statically type safe. For me, actually, that ideally is something, I'm an idealist, so it should not be ideally. A program should be statically type safe, full stop, without any need for casts. If you look at the area the core guidelines cover, there are plenty, around 20 different areas, some supporting sections, and I point that out because some of the myths that people who use C++ for a long time carry, and some of the myths of what good software engineering practice is, also there, and they are demystified. So we have so that's Bjarne worked and Herb and whoever worked on that, were kind of mythbusters. All declarations on top of the functions. That was compiler technology of the 1960s and 70s. No need for that. Single return rule. That comes from the functions that are hundreds of lines long. Those functions need to be refactored first. And usually that single return rule gives things like go to exit, which is also ridiculous. No exceptions. There have been times when exceptions were expensive, and we are currently again striving to get fewer exceptions, but exceptions to guarantee that an object is constructed correctly and completely are essential to the model of C++. One class per source file. That's also ridiculous. Today, some people actually compile a complete project in one file to speed up their builds. That might also be ridiculous, they might have a reason, but one class per source file a class might not be the granularity of things that belong together. What you can put in a source file should be what belongs together. If that's a class or 10 classes that work together, I don't care, as long as it's manageable and you can name that file. One name that you should never give a file is util. Because that means I'm too lazy or too bored or I have too many things in one place and have no idea how to name it. And the core guideline support library is guilty of that as well. And the standard library as well. So, and again, two-phase initialization. Who has code base that uses the init function for almost every class? There was shy. Get rid of that. That's so 1990s, or even it wasn't valid in 1990s. Bjarne would tell me it's not valid in the 1990s. You see, working around problems give us rituals that we never understood why we have them. Now let's check. Yeah, speed up a little bit. Interfaces, don't use globals, except when they are read-only. And even globals can be, let's say, member variables. You freely mutate in your member functions, it might make tests a lot harder. Whenever you want to make some private member function public just for tests, that's an indication that you're trying to do the wrong thing. Then the next thing is actually the main topic of tomorrow's talk is if you use ints or multiple ints as parameter types, it's very hard to call your functions right. Especially you lose all kind of meaning. And Kate said something this morning about using tuple. Don't return tuples except in very generic code. Use structs instead. Name the stuff that you return if you have multiple returns to combine. One rule is if you can avoid defining default operations, do. I call it the rule of zero, and that's where my traffic signs come out. Don't write constructors, copy constructors. Scott Myers did a great job teaching all of us how to write copy constructors and copy assignment and destructors for C++ 98. We are no longer there. You don't need constructors if your class doesn't need any invariance. Doesn't need to guarantee any invariance. A struct is fine. You get everything else for free. If you should use member variables that have value types, then also destruction is easy. Initialization is easy. You don't need these special member functions because writing them correctly is easy to get them wrong. Nico has an objection. No, I'm not saying that you should not write member function. I'm just saying don't write special member functions. And an ordinary constructor is what? An ordinary constructor is not a special member function. It is a special member function, but not one that the compiler provides for you. Okay. If your class has an invariant, then you write a regular constructor, but only that one, not the others. Okay. How can I avoid default operations? Use member variables as variables. No naked pointers at all. Use unique pointer that makes your class move only, which might be a good thing if you manage a resource through unique pointers. You should maybe stay away from plain arrays, which is depends a little bit. You might want to use them, but I much prefer std array instead of that. and because we don't have variable length arrays in C++ for a good reason, the type system. Use member initializers, and use the standard library. When you want or need to get away from the rule of 0, that's actually expert territory. And it became even more expeditious with C++11 because we now have move constructors and move assignments. And doing that correctly is really, really hard. So whenever you have something that is an OO hierarchy, which we now learned with variant from Nico, we don't actually need that much, and Sean Parent has a different trick on doing that. But if you really want it, you have variation at runtime, and you don't want to use variant, and you want extensibility arbitrarily, a defaulted virtual destructor is a must if you allocate stuff on the heap. And that comes with a lot of implications, and there's a nice table and a talk by Howard Hinton telling you what default other operations are available or not, depending on what you define yourself. So if you have a virtual destructor in your base class, make all code, all those classes non-copyable and non-movable. Let's say the smallest change to get there is delete the move assignment operator, which will get rid of all the copy and move operations, which is a good thing. You might sidestep the virtual destructor using shared pointers, but that slide is before I learned to hate shared pointers. Or just use the stuff on the stack and pass it down the call chain like you would do with stream objects, where you define all the functions taking an output function taking an OStream reference, but never actually allocate a stream object on the heap by allocating it on the heap. You just use it on the stack and pass it down the call chain. And we have RAII. And if you write your own container classes, stop first. Think if you really need it. Think if an adapter might be more appropriate to an existing container. And I know there are some special areas where you might want to provide a new container, but if it's really, really useful and generic, submit it to the standard library evolution working group as for standardization if you're really doing a good job. And you might learn which other container actually might better serve your purpose. So expert territory. Even the experts get it wrong. That's the problem. Watch out. Don't leak resources. I skip over that. RAII has been told us a lot, and there are some in the standard library, and I'm trying for years now to get one that's your own. It's in P52, and from that, I have a CPPCon talk telling the story what's behind that. If you ever want to write your own RAII wrapper that is generic, don't try it. You get it wrong. Me and Eric Niebler, we both got it wrong. And I'm not sure it's correct right now, but I hope it is. And I hope that the library working group will find the remaining bugs in San Diego. Other things that people often overlook, taking the address of a standard library function is not sanctioned by the standard, except where it's specifically allowed. So that call is actually creating a unique resource object with class template argument detection is actually, it might work, but it's not guaranteed to work everywhere. So you actually need to write a lambda calling fclose, because calling a library function is the right way to do. That's always allowed and sanctioned. If you really want to write an own RAI wrapper that's not generic, there's another rule. Wrap only a single resource. Because if you have something interesting that needs cleanup, constructing it might fail, and you have two things where either one might fail to construct correctly, it's very hard to get the constructor cleaning up right. With two, it's almost possible, but with three, it gets very, very hard. If you want all or nothing. If you want to combine multiple things in one thing, use them as class members and having multiple resource wrappers in a single class. That's working, but not putting stuff around, let's say, not having 5 plain pointers to 5 different files open in a single constructor. Cleaning them up if one of the open fails is really, really hard. Owner, I think, I'm stand to that. Owner is a thing that's a mistake in the core guidelines, because ownership should be expressed by immediate cleanup, and unique pointer is the way we have in the standard library to do that. Naming and layout. Another bug in the core guidelines, in my opinion. I lost my ribbon, but it's east const. And if people telling you that west const, like the first line in that example here, is the right way to do it, I doubt it. Read Dan Sachs, he told us all how to spell it. It's int const y, because then I immediately see that y is const. Even if it's auto const y. You have the, since I'm despotic, you have the freedom to be against me. And if you use developer IDE, you can actually set a flag on where you want to place the const, and it will change all your code base consistently. So even if you have, all of our code base is east const and we want west const, just change it. Or the other way around, which is a better option in my opinion. Constants, as I said, we have that const cleaner, and there are 5 rules in the core guidelines where things where to place const, except for the const x, which we haven't targeted yet. The first 4 are implemented more or less good. You might get some false positives still, but if you have them, tell us, we might be able to fix them. Like, okay, there's a variable in a local variable that's never changed after initialization. Make it const, and it actually, the tool will not only flag it, it will provide the const for you on your choice. Do it. Get your code const clean. And even if you just use develop for that, and then Visual Studio or whatever other IDE you're using, just do it. I want to get rid of bad code. There are plenty of rules of functions. There are plenty of rules on class and hierarchy. I'm also not a fan of all of them. Like C2, use classes. If the class has an invariant, use struct if the data members can vary independently. I prefer to use struct every time because I want my code to spell out what the class actually does, what are the major functionalities up front. Especially since IDEs tend to show the definition on hover, it's very easy to spot what the class is for. If I hide that by using having to write public somewhere and first maybe even spell out my member variables, it might not actually show what it's about, and that's why I prefer a struct. I save one line in the hover and get more information. And it's equivalent anyway, so that's one of the things. Support library, I'm not a fan of owner, and I'm not sure if I'm a fan of not null or not. With contract support, there are expects and ensures macros that are superseded by C++20 contracts, which we voted in Rapperswil, so we get contracts in C++20 unless something weird happens, which is never sure until the standard is printed in Geneva, but let's hope for that. And Bjarne fought hard to get that, so thank you, Bjarne. There's utility, there's a scope guard functionality, and even though my unique resource paper introduces scope guards to use, I'm not sure if scope guards is curing a symptom that is because you didn't use RAII correctly. So that's why I'm not sure if finally is really the very best idea to do something. It's more or less kind of like owner. It's an RAII in waiting. If you have some specific extra cleanup. So it's kind of hacky thing. and we will hopefully provide that in the standard library with the scope guard classes. But I'm still not sure if that's really something you should design around. And there's span and string span, and we have string view in 17, and maybe hopefully span in 20, and other things. RevUp. The core guidelines can help you get rid of your old style C++ code, and most of the stuff you can actually change incrementally. There are IDEs like C-Line or Visual Studio or CVelop helping you to do that. Always, if you want to define guidelines, take them with a grain of salt. Look at them, select what makes sense for you, especially if you want to adopt them. If you just be despotic and say, apply all the core guidelines, your developers will love you, because 477 pages as of today, printing them is a lot of things to learn and get your head around, and we don't have tools that cover all of them yet. And Clang also has some tooling around that. And please try CVelop. It's free. Give us feedback. We want to improve that because we want to get rid of bad software. This is just a list of what my students implemented. Some of the stuff works, some of the stuff is as always, but we try hard to make it a product quality in all of the areas, and we're on our way to refactoring that. It's just a matter of having enough resources and funding to do it, but we will do it. And that's our campus, and you see the lake actually in winter, and winter is coming, but not the bad things, hopefully. And whenever you have questions, feel free to grab me and ask me. And we don't have time for 2 questions, but I have 2 hats to actually give away. So I can take 2 questions. No question? Bjarne? Yeah, you already have one. Oh.
I don't need a hat, and it's not a question, it's a request. You clearly have insights, feed them to the core guidelines people. If you are too embarrassed to put your opinions down on the GitHub, send the email to me, where we decide that your ideas are good, they'll go into the guidelines. If we decide the ideas are bad, there will be a comment explaining why we didn't go that way.
I've done that already, and I got comments where I think the commenter's perspective and mine just differ. Yes, and that happens. And I'm showing my perspective here. Yeah. That's it. Sure. Yeah. So for some of the things I done that, some of the things I was too lazy to do it. Yes. I saw. Anything else? So, who wants a hat? Nobody. You were the first that I've seen, and you were the second one I've seen. Sorry for those who sit to the side. I have 2 more tomorrow, so maybe think about a question you want to ask tomorrow, and maybe we are not running out of time like that tomorrow. One final question by me. Who has actually used CVelop so far? I know of one, but he's using it because I kicked him hard enough. So if you want to learn more about it, I have some flyers to give you. So if you want to learn about my perspective, what a modern IDE should do for C++, grab me. I can hand you a flyer to take home to try it or not. So enjoy the rest of the afternoon.